Okay, so we've got a car on a hill going down the hill, and that's our car. It's going at 20 meters per second, constant speed, there's no acceleration. And what forces we got? We got the weight going straight down, that'd be 800 G. There's a resistance to motion of 1300 newtons. We've obviously got normal contact force R, and we've got driving force here. And I know that the power is the force times velocity, so in this case it's dV. And power, I'm told, is 10,000 equals D times V is 20, and so D will equal, divided by size by 20, will be 500. So I've got that bit now, and now I can resolve down the hill. Because I've got to find, I've basically got to show and find alpha. That's alpha there, that's alpha there. So what have I got going downwards? I'm going to have resultant force equals mass times acceleration. There's no acceleration, so I could have had it downwards equal upwards, but I'll do it this way. So I've got D, which is 500, plus 800 G, and that'll be this bit here, do it in pink as usual. That'll be the sine alpha, and minus the 1300, and that will equal 800 times 0, which is still 0. And so that means that sine alpha will be, that'll be minus 800, add it to the other side. So that'll be 800 over 800 G, which equals 1 over G, or 1 over 9.8 by times top and bottom by 5. That'll give me 5 over 49, which what they wanted to show me that sine alpha equaled. Marvellous. And now the second part, I'll do it in red mostly. It's going to go uphill. So it's now going up the hill, and it's like so. And let's put the weights and forces in there first. 800 G. We've got the driving force now. We got still the 1300 going backwards. We've still got a normal contact force. Probably won't use that. And I think power is different, so let's put the power in there. So power equals 20,000. And the angle is sine to minus 1 of 5/49. We've got the same angle in there. And that's it. Calculated time, it's gone from 0 at the bottom, 0 meters per second. At top of the hill, it's now going 8 meters per second. And that distance to go from there to there is 22.1 meters. And this is going to have to be an energy thing. So I don't know about whether we've got constant acceleration. I don't know that. So I'm going to have total initial energy. And I'll do it down here. So it's going to be quite a long formula. So I've got total initial energy equals total final energy. But there's also work put into it, and there's also work taken out. So total initial energy, the final energy is going to be increased because of the work done by the engine. So I'm going to have on the left hand side plus work done by engine. That's that, and therefore work over here I'll have to be work done against friction, or against the resistance. And initial energy is potential energy mgh plus half mv squared. Always want to write that down. So work done. Okay, well, we got power over here. We know that power equals work done divided by time, and so we want to have the work done. So work done will equal power times by the time. So that will equal power is 20,000. And t is what it wants us to find, calculate time, so that's good. So that's given me a t in the formula. So 20,000 t plus initial energy, well, I'm going to call that 0 for the mgh, because I'm going to take the baseline to be there, and also the kinetic energy will also be 0. And that will equal the final energy, which will be mgh, so it'll be 800g, times by the h. And in order to work out what that is, I need to know how high up it's gone, up there, when it's gone across. I know the hypotenuse is 22.1, and I want to find the opposite, so that'll be so, and that's going to give me the opposite equals sine of alpha times by the hypotenuse, which is 22.1, and so that will be sine, that'll be 5/49 times by 22.1, which would be 2.255102041. So now I know what that is. So that will be times by 2.25510241 plus kinetic energy is a half times by m, which is 800, times by velocity squared, which is 8 squared at the top, plus the work done against friction, which is force times distance, which is 1300 times by 22.1. And that will say that 20,000 t equals, that all comes to just numbers in there now, 72010, and so t will equal 3.6005 seconds. And that's sort of like exact, or 3.60 to 3 significant figures. And I hope you follow that all the way through. At least it's colourful. And that's question 5 done.